everyone. We'll be starting. So I'm Daniel, this is Mu.
Yeah.
And you are not here to hear our biographies, so I am going to skip that step. But I have to start with a very small disclaimer. Both me and Mu, we are employees of Avanade, which is the #1 partner of Databricks. We have came here with support of our employers, and we are also Databricks champions. So we are working with Databricks on a daily basis, so we're quite deeply in the ecosystem. However, we are here today to speak first and foremost about our own experiences, our own views, based on what we have seen with our clients, based on what we have kind of learned from our colleagues and our own previous experiences. So before we talk about building intelligent data platforms, let's take a bit of a step back and look at the history. But not the traditional data warehouses plus data lakes, now lakehouse view. Let's take a bit of a different spin on what has been happening over the time with our data platforms. At the beginning, things were, it's not fair to say simple, but they were clearer. We had our core data systems, wanted to do some reporting on them. We took the first off-the-shelf data warehouse, everybody was happy. If you were working in a large enterprise, you were dealing with acquisitions, mergers, multiple legacy systems. Things were getting a little bit more interesting, but still, you could just throw a finite number of engineers, finite number of consultants, and be pretty sure to get some sort of sensible results. But as time went on, things were really starting to get interesting. Data sizes were growing exponentially. Every single device became a data device. Trains, cars, my dishwasher, everything is generating data. At the same time, some of the more digital native companies, data native companies, started doing things like machine learning, started using the unstructured data, and really running circles around traditional business models. Oh, and let's not forget about this little thing called global pandemic, which made sure that every single company has digitized their business in a matter of 3 months. We were there. But as time went on, over the last few years, we're really standardizing. We're really starting to solve some of those problems. We've got lakehouse. We have got all of this nice innovation going on in the open source world. Even for the more distributed needs, for like the largest enterprises, we've got the language, the reference, the data mesh conversations to help address all of those challenges. But just as about this was happening, again, everything went up in flames. GenAI. Everybody needs to do GenAI. Every single business process must be AI-driven. We need to have our data ready for artificial intelligence in every single process. So we are now back into the interesting, chaotic space. Now, who here already recognizes where I'm going with this? Anybody? So there is a thing called the Kinefin framework. It's a decision-making framework. I encourage you to check it out because it's worth a session on its own. But it does have very important implications for how do you make decisions, what do you focus on in specific domains depending on what are the characteristics. And today, we really argue that most of companies we are talking to, they are in this complex space. And it has some very specific characteristics. Some of you might be more in the chaos zone if you have no clue what you're doing and just really trying to get your bearings when it comes to your data platforms. But we kind of believe that we will be focusing today on the complex environment. And the complex environment is characterized by those key observations. And to address, the situation we are in, we need to be quite flexible. We need to keep experimenting. We can't really rely on planning things 10 years in the front. So today, what we're going to do is we're not going to be talking about use cases. We won't be talking about business aspect of looking at data platforms, because there are other sessions where this is beautifully into. But for today, we'll really focus on our observations and what are the actual implications for the design of data platforms and turning them all into specific guiding principles, which we hope you'll be able to use when talking to your teams, talking to your vendors, your consultants, and really use them as reference starting point. Because we are looking for those islands of stability, islands of sense in this chaos, which we can build our decisions on top of. So, Mu, what do we actually know about data platforms?
So we are clearly the golden age of data and AI, right? The innovation that's happening and the data strategy is now the key, right? You have to have a solid data platform to bring trust and transparency back to your data and to make it usable, accessible, and seamless to apply to all of your AI, ML, and GenAI models. So with that being said, first and foremost is lakehouse is the standard for building your modern data platform. Why? Because it enables the flexibility of data lakes with the reliability of data warehouses. It enables you to combine and process flexibly, efficiently, and reliably all kinds of data, structured, unstructured, and semi-structured. So we know that 80% of organizations' insight is in unstructured format, right? So the platform, and you also know that data lake gives you scalable, infinitely scalable, inexpensive cloud object storage, which is detached from compute. And your data lakehouse will enable you to store data in its own original format, like a data lake, while also providing you the data processing and analytics capability like a data warehouse. So you get the best of both worlds. Lakehouse will also provide you a unified platform for both data and AI assets and will scale with changing growing needs. So that's and then what are the value addition? So you are going to be able to use the same copy of data and to be able to provide both historical and predictive analysis on that same copy. So it kind of reduces your data silos and it gives you a consolidated, unified way of processing your data. The value drivers are, it will lower your total cost of ownership. You will be able to eliminate complexity and reduce cost by retiring some of your existing legacy system. You'll be able to reduce data processing cost and improve the data team's productivity. You're also going to be able to accelerate realization of value from streaming, data warehousing, and data science use cases, so all kinds of use cases. And you will also accelerate innovation and open up a vast market of potential data customers for your platform. And Lakehouse, this flexible, scalable, and intelligent data platform will also enable you to satisfy all kinds of, to give you better performance, lower cost, scalable, I would say scalable infrastructure, and be able to give you the benefit of building your modern data platform. Next is Lakehouse is also built on open source and open standard. And you know Delta Lake is open source storage format on which the Lakehouse is built on. And that is one of the open source format. You can also use Apache Iceberg and Apache Hudi as well. So being open is extremely crucial for any modern intelligent data platform. Why? Because then you open up the vast community of open source community to get the innovation coming in. And you're also being able to interoperate. You are able to become an interoperable business, whether it is across domains, clouds, or infrastructure or platform or anything, right? So being open is crucial, and Lakehouse platform enables you to do that. It will also enable you to become a interoperable business, an interoperable ecosystem, and an interoperable industry as a whole. So you are no longer locked down into a proprietary format. If you are building on a closed data format, then chances are you will have to redo your modernization project again, and this is going to waste your resources, which you could have invested on improving your AI or bringing more value for your AI investments. So crucial is that you build an open source Lakehouse platform when you are modernizing your data infrastructure. Next is being multi-cloud and multi-region is the business reality in today's global economy. That's why we see 92% of enterprises already has a multi-cloud strategy in place to reduce operational risk, to adhere to regulatory requirements, and also to benefit from choice of cloud services and prices from multiple vendors. In addition, any local and global enterprise also has multiple domains and data systems to manage and collaborate with. So your data platform has to be distributed, domain-oriented, modular to enable easy collaboration across domains. It cannot be centralized, monolithic, or siloed, hyper-specialized. Organizations need to be able to enable collaboration across line of business, such as business to business or business to consumer, or with outside vendors and third parties. So based on our experience working with many large enterprises, we recommend using distributed domain-oriented data mesh architecture. Data mesh it's not a technology stack, it's an architectural pattern. It'll enable the domain team to manage their own data, thereby it'll improve the responsibility and the reliability of the data or the quality of the data. It'll also treat data as a product, thereby making sure that it is being used, treated as valuable and being used by different teams within your organization. This approach also supports use of common tools for data management and processing, and also deploy to multiple different cloud platforms while adhering to organizational standards and regulatory requirements. Another thing I wanted to mention, is Lakehouse Federation is another that you heard today at Event to GA, which basically enables you to query data sources with scalable governance from multiple different data sources without the need to copy data. So that's another way to federate your platform. Next is, did you know that 80% of organizations seeking to scale their digital business is going to fail because they do not take a modern approach to data and analytics governance. So unified governance is crucial and fundamental for your platform. Not only unified, but unified and simplified of all of your data and AI assets. Effective governance will solve the challenges of data chaos. It will provide you easy access control, secured access control, sharing, discovery, lineage, monitoring, transparency, reliability, and quality. Let's Gartner forecasts that by 2026, 20% of large enterprises will adopt a single platform for their data and analytics governance. So here is why unified governance is key. Number one, it will enable you to easy access control. What does that mean? Meaning you are able to provide access to sensitive data only to the right people, thereby you are keeping the information safe. Your platform should enable you to be able to comply with GDPR and CCPA regulation. Also, it should provide you the ability to give fine-grained access control, enable PII and PHI data protection, and etc. In terms of sharing, the platform should also enable live, efficient data sharing across domain, clouds, and regions with strong security and governance. In terms of discovery, the platform should enable all of your data team to be able to easily find data, thereby able to work together better and make decisions faster. In terms of lineage, the platform should enable you to be able to track how your data is being collected, transformed, and consumed, which is vital for compliance and auditing, right? The platform should provide you automated lineage all the way down to column and table level for all of the workloads, which will basically enable visibility to the end-to-end flow of your data within your platform, how the data is collected, all the way down to how it is being consumed and how it is used for training your AI models. In terms of monitoring, the platform should keep an eye on how data is being used or processed, how data is flowing through the system, and how AI models are being built. That way, it can take care of any issues or any problems appearing into the system automatically. In terms of quality, which is not mentioned here, but that is also a vital requirement, what it will enable you is give you, make your data products and your AI assets reliable. It will provide you automated alerts based on drift of your quality score, whether it is on delta table or on the prediction of your AI models. So it will enforce trust and bring transparency to your data as well. Next, so let's visualize all of these architectural principles into a graphical fashion to make it easier to perceive. So as we talked about, open lakehouse at the core, which is built on top of cloud object storage, and your platform is loosely coupled but cohesive foundation. So you are enabling all of your domains and business units to be able to collaborate efficiently, securely, in a governed fashion within and outside of your network perimeter of your enterprise, both with outside vendors as well as with on-prem systems. And the platform has unified governance of all of your data and AI assets, which is providing you lineage, transparency, quality, security that we talked about. So the third bullet, I'm going to read it just to emphasize. So fundamentally secure and compliant collaboration for both your data and AI assets across tools, jurisdiction, business entities, clouds, and regions. So next.
We have our first three basic principles we wanted to convey to you. I think what's really important here is also to mention that there are reasons to stray away from them. But if you are really not taking them into account, at least as a consideration, you're most likely building essentially legacy today. And please notice that we are here highlighting those specific points: data and AI, tools, jurisdictions, entities, clouds. It's quite a mouthful, but we believe these are really important concerns to at least take into consideration when you're designing your next platform, your next evolution step for your enterprise ecosystem. So let's take now a little bit a double click. Let's focus a little bit deeper on what we can further figure out, what are the things we really believe in right now are the right ways to do about data. So let me start with a bit of an observation. If we look at what was happening with GenAI, the companies who are creating those models, whether open source or the OpenAI and everybody else, they have essentially used most of the publicly available data to build those models. And now, all of this knowledge, all of this power distilled in the models, the baseline models we can use, foundational models, it is something I can use today. It's something you can use today. You can use it. Everybody can use them. They're all at our fingertips. So it puts an interesting question. So how we can actually use our data ecosystem to an advantage? And what has been happening in a kind of related zone, the zone of DevOps, around 7 years ago, when we kind of in the middle of this DevOps revolution, there was some very interesting research done, which essentially linked how well you are doing software engineering, how well you are doing your development and operations, essentially, to the financial results of companies. And obviously, over the last years, our DevOps practices matured, right? There isn't such a massive difference between different organizations today. But if we have the same access to the same powerful AI tooling, we have access to the best practices for operations, for development, for software engineering. This kind of leaves us with the point that how well we are dealing with data will be directly the predictor of how well our business will be doing. There is a direct correlation between how healthy our data ecosystem is with financial results. And that kind of comes back to the points that Mu has just mentioned about all of those things we need to make sure are there handled very well. So let's try to turn those observations again into more specific things you need to expect, you need to talk about from the perspective of design of your platforms.
Okay. So businesses are finally ready for real time. And when it comes to the most important requirement for infrastructure, there was a survey done by Databricks, and it was asked, the survey participant, what's the most important thing for data infrastructure to support AI? And 72% of respondents say that streaming data workload for real-time analytics as important. So your modern data platform needs to be able to handle real-time data processing efficiently alongside batch processing. Streaming data will improve the accuracy and actionability of your analytics and AI. Your business will benefit from real-time insights coming in from, and also your platform needs to be able to enable all of your data teams to easily and quickly be able to build streaming data pipelines with the language and tools that they already know. Next is streaming data will also enable your business users. Your platform needs to enable your data practitioners to easily and rapidly build solutions that bring together signals from different parts of your business and provide high-value insights and alerts and orchestrate operations in a real-time fashion. So your modern data platform should simplify the development and operations by automating many of the production aspects associated with building and maintaining real-time data workflows. This can also have a real environmental impact if signals from your business can be found and turned into insights easily and quickly. So your platform needs to be able to support all kinds of workloads: real-time, streaming, data engineering, data science, AI, and GenAI. Next is the goal as the platform will provide based data-focused authoring experience to your scientists, data scientists, engineers, and SQL analysts. It should boost developer productivity with AI by improving the workflows and minimizing the mundane tasks and enabling them for faster delivery. It should give your developers more time to focus on innovation and creativity. For example, platform should also enable your developers to accelerate code development with GenAI workflows that will deliver automated code suggestion, code completion, will document their code, and also will enable them to build solutions and collaborate seamlessly using self-service tools and flexible, easy-to-use solutions backed by a commitment to open source and DevOps practices. Platform should also provide intelligent search capability to your data practitioners using semantic search so that they can get insight from their data and AI estate easily and be able to deliver business value. Next, the platform should also optimize resource allocation, should be intelligent to optimize resource allocation automatically and reduce your administration and operations cost. And it should, by using AI-powered insights from your historical workload, it should automatically tune, configure, and administer your platform such that it'll save you cost and money and you don't have to do it on your own. So every dollar you spend by not using legacy platform is one you're saving to enable you for AI enablement and innovation and valuation. Next, okay.
So we have another set of principles in here, but let's once again delve a little bit more into use case level, specifically GenAI level conversations. I think it's absolutely fair to say that the last year was the year of proofs of concept. So there's a quick, maybe a show of hands. Who has worked on a proof of concept GenAI project in any way in your company last year? Okay, almost everyone. Who has took this to production? That's a little bit less, right? So obviously, everybody is excited about GenAI. Everybody wanted to figure it out. It was a revolution, right? Not everybody was expecting this type of immediate change to happen. Not every business was equipped to deal with this rapid change. And despite that, we're quite quickly trying to standardize on that, right? So right now, no matter which vendor or platform tooling you choose, if you go to the documentation, you will find one of those diagrams which tells you how to do GenAI with rack architectures, for example, right? But I think the interesting observation we can make in here is that those architectures, like RAG implementations, those simple, low-hanging use cases, POCs, demos, they are not really that much aligned to real AI problems. What I mean by that is that if you look at the operation challenges, deployment challenges, the actual development and the whole workflow around those projects, they're much more closely aligned to traditional application engineering. So if we try to then scale it all up, and not only just take it into production, but create a whole like factories that push out new business use cases with GenAI embedded into it, it's a completely another set of problems, completely different space of the problem. And when things go wrong, especially with GenAI, they go wrong quite spectacularly. I'm sure you have seen those articles previously, right? And the interesting thing here is that the challenges we have seen, those kind of high-profile failures, are not really new things. Because even before last year, we had whole books that outline how we as kind of like industry were failing to use AI and algorithms well, how we're essentially introducing biases or really making people's lives worse because of the way we have been mishandling AI and data. To add on top of that complexity and risk, we can come back to what we started with, the complexity conversation. We are currently in an environment where absolutely massive amounts of money are being poured into new GenAI tools, products, models, everything else. And on the other side, we have governments really starting to catch up with the policies, which also affect what we are building and what we are doing. So we are in this environment with those, I would say, constraints. So what does it want from our platforms?
Yeah. So 90% of enterprises, as Daniel was mentioning, are not confident going to production with their GenAI solutions. Why? Because it's not just about good models. They need more than good models. They need to be able to have complete ownership over their data and models. And faster, they need to be able to deploy rapidly in a reliable fashion across multiple use cases and be able to build LLMs at scale with cost efficiency. So enterprises are no longer blocked by the models. It is now about the data. So your data needs to be tuned, and your platform should enable you to use your data to tune and evaluate these LLMs for real world business use cases. These LLMs needs to be customized for enterprise specific use cases. So the key challenges are model transparency, model explainability, model portability, and economically, how to do it in a cost-effective fashion, right? So the intelligent data platform that you are going to modernize will address all these challenges by providing a strong data foundation that will enable the implementation of robust compliance and governance framework, which will ensure that the AI products are developed and managed responsibly. And you need a unified data-centric platform for both MLOps and LLMOps. Now, to give a background of MLOps provides the essential scaffolding for developing, deploying, and maintaining AI models at scale while ensuring they remain accurate and continue to deliver business value. Now, LLMOps emerged with the advent of GenAI and for the specialized needs of GenAI. However, it remains rooted on the same foundational principles of MLOps. So whether you are implementing traditional machine learning models or LLM-driven applications, the 4 core tenets that you need to keep in mind. Number 1, always keep your business goal in mind. Number 2, prioritize a data-centric approach. Number 3, implement solutions in a modular manner. And number 4, aim for processes to guide automation. And as we look forward to the upcoming wave of AI advancements, it's clear that employing a robust MLOps strategy will remain central to unlocking AI's potential. With firm MLOps strategy, you will be able to gain value and be able to get return on investments on your AI investments, return on benefits on your AI investments. Next is choose a platform which is going to give you innovation in a continuous fashion. Things like being open is also enabling you to get the interoperability across platforms, domains, clouds, right? You are able to get innovation coming from worldwide open source community. And things like serverless compute, try to use out-of-the-box features as much as possible. In Databricks platform, things like serverless compute, auto-scaling, DLT for Delta Lake pipelines. And you also heard about Delta Lake 4.0 has been released, which is going to give you variant data type for JSON file processing, as well as deletion vector, which is going to auto-optimize the platform. So keep in mind when you are selecting the platform to choose a platform which is constantly innovating, and being open source is going to also enable you to open up your ecosystem. Next, your data is your gold mine, as Jensen Huang was mentioning today. So focus on your unique IP, which is your data. Use that data to train your models, and that's how you can monetize your data and your AI models, and be able to deliver business value to your customers and beat the competition. So overall, we talked about all these guiding principles. We are not going to read those out. These decks are going to be shared, so you can probably follow through this. What this means, when you are going through tool selection in terms of your modernized platform, keep these principles in mind as true North Star, which will help you to make better decisions.
Yeah, and we did keep them quite high level, completely on purpose, because to turn them into like specific architectural drivers, you need to account for a specific situation. And it is actually there are perfectly reasonable deviations you can make from what we are putting in here. It's just that we really think that if you're straying away from that, there are reasons to do that, but you're most likely doing something that will end up as pretty much legacy at some point in time. So yes, I have seen a lot of people taking pictures on other slides. This is probably the slide that you want to see, and this will be also available later. But now looking at them, I mean, we're on the Databricks conference. Let's try applying that in a little bit more practical way, right? So if we're designing platform, we can quite easily fill in that slide with a technology coming from our partners. And even if we take this to one level up, obviously there are many different options. We are also big fans of the best of both worlds, or better together, between Databricks and Fabric. So there are ways you can address at least the technical requirements of such a platform with the technology stack that has been discussed over the last 2 days quite intensively. And as one more final observation and takeaway, I wanted to bring your attention to kind of this situation we found ourselves in historically. So from the point of time where we got data warehouses to the point we really started focusing on data lakes, it was 30 years. From data lake houses to really the rise of the lakehouse, it was 9 years. Lakehouse right now is the standard, 3 years. And ChatGPT, it was released essentially a little bit more than a year ago. So we're in this environment where everything is changing quickly, and kind of even more quickly with every single period. And this brings me to one thing which we could not speak about today, because it would not take us 40 minutes, it would take us 2 days to just scratch the surface of it. So besides what we have told about our observations and about more the practical impact on what we believe needs to be built, there's the whole question about how do we actually make this a reality? How do we build those projects? How we design them? So that's something I think we will just do some high-level lessons learned.
Yeah, sure. So obviously we are the SI partner for Microsoft and Databricks. So because we have done a ton of migration and modernization projects, we would like to share our lesson learned with you. Did I click? Okay, so we would like to share our lesson learned based on our experience working with many large migrations. Number one, use a phased approach. Migrate gradually your workloads to minimize disruption and ensure that the legacy system can still function during the transition. Number two, invest extensively in training programs and workshops in new tools and technologies associated with the modern intelligent data platform to bridge the skill gap in your workforce, if any. Number 3, implement a comprehensive change management strategy to basically actively engage with your users and address their concerns. Number 4, use industry solution accelerators for migration. They will provide you standardized frameworks for data transfer and validation. Therefore, they are going to significantly speed up your migration process while ensuring data integrity. So we have some of these accelerators too. We are not here to sell those. However, you can always reach out to us and we would love to work with you. One of the biggest challenges of implementing distributed domain-oriented data mesh architecture on lakehouse platform is how to balance the autonomy of domain teams with the need for standardizations across the organization. So from our experience, address this by establishing a federated governance model that will provide a framework for standardization while allowing domain teams the freedom to manage their data. Also form cross-domain data governance council with representative from each domain. Use Databricks' Delta Life tables to create repeatable, reusable data processing pipelines to make it easy to adopt standards. Develop a set of minimally viable standards that all of your data team needs to adhere to. Things like standardized data formats, naming conventions, metadata management requirements, etc. And also try to utilize out-of-the-box feature as much as possible, like auto-scaling capabilities to dynamically adjust resources based on workload demands, and use serverless compute as much as possible for base price and performance. And one of the most important thing is security requirements are crucial, vital. Make sure that those are considered from the get-go of your project, starting from the design phase. Don't wait for taking care of security requirement at the end of the project because it will create huge amount of rework for you. And use Delta Lake's features. Make sure that your data teams are not reinventing the wheels. They are using the features which is coming out of the box of Delta Lake for schema enforcement and evolution and etc., duplicate removal and all of those things. So with that, I think, yeah, so these are all the different things that we covered for lesson learned. And we already talked about guiding principles. And Daniel, you want to say something?
Yeah, okay. Just to maybe wrap it up, right? So we really hope you will make use of them, right? So when you talk to your teams, when you talk to your consultants that are talking to you, right, like us, just kind of ask them about this, right? Ask them what they are thinking about this, how they are going to implement those concerns for your next generations of platforms. Talk about them to your teams. And we'll be here for any questions. So yeah, feel free to come up here. And that's all we had for today for you. So thank you very much for staying here with us, despite this being quite a late hour for the conference. And yeah, thank you very much for listening.
Hope all of you have enjoyed this Data and AI Summit and have a safe travel back home.
Yeah.